Okay, the third way, this is the new one that we're going to talk about. Now we're going to apply the opposite operation. Okay, so here are the steps for this one. So the goal of this is to isolate the variable or get the variable all by itself. So that something where a variable is all by itself would be like that. The variable is on one side of the equal sign, all by itself here. And that's what our goal is. Okay, so the way we're going to do this is we're going to use opposite operations, an operation that undoes another operation. So the ones you need to remember are, we have our four operations. Subtraction and addition are opposite operations. Subtraction undoes what addition does. For example, 2 plus 7 equals 9. If 9 subtract 7 takes me back to 2. Multiplication and division are also opposite operations. So 2 times 3 equals 6. 6 divided by 3 equals 2. Okay, so we have to remember addition and subtraction are opposites, and multiplication and division are opposites. We also have to remember the left side and the right side must maintain balance and equality. Also, whatever I do to the right side, I have to do to the left side. Whatever I do to the left side, I have to do to the right side. Okay, so the operation occurring in this one, as we see here, okay, is subtraction. So I want to add. So if I'm taking away, I'm going to add 9. I'm going to add 9. So I have x equals 3 plus 9 is 12. Now I want to verify this, so I have x subtract 9 equals 3. 12 subtract 9 equals 3. 3 equals 3. X equals 12. K subtract 4 equals 1. Now again, this one is fairly simple. We can do this with inspection. Something subtract 4 equals 1. So K is going to equal 5. But we can do this using our opposite operations to show. Okay, so we're subtracting 4. So I need to opposite operation add 4. That cancels that out. Plus 4. We now have the K isolated. 1 plus 4 is 5. So we're saying K equals 5. So I verify this. I'm going to do K subtract 4 equals 1. 5 subtract 4 equals 1. 5 subtract 4 is 1. Therefore, K equals 5. So with addition, B plus 8 equals 13. So we're adding 8, so I want to subtract 8. So I'm going to subtract 8 from this side. B is isolated now. 13 subtract 8 is 5. So now we have our answer. We think it is B equals 5. So we're going to verify this. B plus 8 equals 13. Our B, we're saying it's 5 plus 8 equals 13. 5 plus 8 is 13 equals 13. So there is my answer. Okay, so the operation occurring here is addition. So I need to subtract 7, opposite operation. Subtract 7. Now I have the Z isolated. 4 subtract 7 is negative 3. Okay, so now I'm saying that Z equals negative 3, so I'm going to verify this. Z plus 7 equals 4. I'm saying Z is my negative 3 plus 7 equals 4. Negative 3 plus 7 is 4. So my answer is verified and correct. Z in this equation equals negative 3. What operation is occurring in this? So I look at my expression on the left, and this is multiplication. 2n is 2 times our unknown number. So if multiplication is occurring, I have to perform the opposite operation. So I have to undo the 2 times the n. So then I would divide this by 2, okay, which gets rid of that 2. And I also have to do the same thing to the opposite side. So now I have the n is all by itself. 32 divided by 2 is going to be 16. 2n equals 32. 2 times 16 equals 32. 32 equals 32. So I have now verified that this is correct. 4n equals 36. Okay, the operation that is occurring in this again is multiplication. 4 times n. So then I need to do division to undo this. So I'm going to divide it by 4, which eliminates the 4. I'm going to divide the opposite side by 4. N equals 36 divided by 4 is 9. Okay, so now I want to verify this. So I'm going to n 4n equals 36. 4 times 9 equals 36. 36 equals 36. Okay, I've now verified that my answer is correct. N divided by 2 equals 3. We're trying to solve again. We're trying to figure out n equals something to make this equation correct. So again, the operation that is occurring here is division, so I need to multiply this, which is the opposite operation. So we're dividing by 2, so I'm going to times this by 2. Okay, and that undoes and gets rid of that. So then I have to also do the same exact operation to the right side. So I have to times the 3 by 2. So now I have n all by itself, isolated, equals 6. N divided by 2 equals 3. 6 divided by 2 equals 3. 6 divided by 2 is 3, equals 3.